So quite a lot of people have been trying to create an AI system like Jarvis from Iron Man, but since we are a long way from AGI and we do not have access to any open source GPT-4o, that's an Omni model, we will be making do with what we actually have. And for our AI system, we are going to set it up locally. And hello, MegaMind, open your eyes and tell me what you see.
Please hold on while I turn on the webcam and analyze the image. The image shows a piece of lined paper with several doodles drawn on it in blue ink. In the center, there are two drawings of eyeglasses, one above the other. Both have thick frames, but the top pair is more rounded while the bottom pair has a more angular, pointed shape. To the left, there's a doodle resembling the sun with rays emanating from a circle. Below it, a partial circle is visible, possibly part of a larger doodle that's cut off by the edge of the image. On the right side, a more abstract doodle.
And for this particular video, we're going to split our AI system into three different sections. We have the input, we have the processor, and we have the output. Now for the input, we're going to be working with a speech-to-text engine for transcribing our whatever we actually say to text, so we can actually pass it to the LLM. And in this video, we'll be using Whisper CPP. We would not be using the Python library. We are going to be using the main Whisper CPP library that's written in C and C++. And I'm going to show you how to use socks to access your microphone and also use it as a source of audio. And I'm also going to show you how to use speech recognition to use the microphone function from the speech recognition library as the source of your audio. And at the end of the day, we are going to be able to transcribe whatever we say through our microphone to text and pass it to our LLM, which is the processor. And for this video, we're going to be using Mistral 7B, the version 0.3, which basically came out, I think it's been over 2 weeks now. Yeah, as of the time I'm recording this video. And we'll also try it out with Llama 3, the 8 billion parameter, which is really good for tool calling and function calling. Both are really good for function calling, but we just want to see if our prompt and every single thing would work on both of them, on both large language models. And for our multimodal capabilities, we're going to be using Gemini 1.5 Pro. And at the end of the day, we're going to also try out Lava 13B or Lava 7B. We are going to try it out. Since we are actually setting this up locally and privately, we are going to definitely set up Lava 7B, and we are going to switch between Gemini 1.5 Pro and also Lava 13B. So it's definitely up to you. You can use whichever one you want, and I have a video on how to actually set up Gemini 1.5 Pro with by creating a Google service account in your Google Cloud Console, and I'm going to drop the link to that in the description. And I also have a video on how to use a vision tool, which we are going to still use in this particular video, and I'm going to drop the link to that particular video as well. Now for the output, we're going to be using a text-to-speech engine, and primarily we are going to be using Piper TTS because it's really fast, and you can use 11 labs, you can use wherever you want, but this is going to be set up local on our machine. And just in case we're not connected to the internet, I want the core, the main systems and the main three sections to actually function without any problems. Now you can actually try out Open Voice version 2. I have a video on how to set up Piper TTS and also Open Voice version 2, and I'm going to be dropping the links in the description also. And I can only recommend Back by Suno AI to people that actually have a beefy GPU that can actually run it, and it's going to run real fast. It's going to generate the audio real fast. And since we want to build something that's going to be interactive, an AI system that's really, really interactive, we do not want any other latency apart from that latency that will come from the agent executor, since we're actually using Langchain as our framework of choice. Now, let's get right into the video and let's go over to the code. Now, for our requirements of TXT, I have Langchain set to 0.2.1, and I have this over here, which we'll use to interact with Gemini 1.5 Pro. And I also have this, which sometimes this actually requires this. So I also have the python.env here to load our .env, which we actually have here, into our script, our Python script. And I have OpenCV, which we'll be using to access the webcam. And I have PyAudio also. and I have the pillow library, which we'll be using to convert our images to either base 64. We can use it to convert it to RGB for for getting better description from our LLM. And I have open Whisper here, and the reason why I have this and also have these two is because they're actually required, since I'm actually using an Apple Silicon, for me to be able to get core ML support on Whisper CPP. I would actually need these two. So at the end of the day, I have the speech recognition. Like I said, we'll be using this, and I have Pygame. We'll be using Pygame Mixer to play whatever audio Piper TTS actually generates, and I think that's basically it. And we have socks. It's every other thing. It's really straightforward. And let's create our virtual environment, which is actually recommended. If you haven't created yours, you can just do that. And I'm going to create mine. Since I'm using VS Code and I have the Python interpreter extension already installed, I'm going to just do it this way, and I'm going to select the requirements.txt, and it's going to create it, and at the end of the day it's going to install all the packages that we actually have here in the selected requirements.txt, and it will activate the virtual environment for us, and we can get right into the code. Now if we go over to main.py, we have a very simple script. Basically, we have the voice service. As you can see, we have this, so we will be saving all our memory, all our chats history into this JSON file that's here. So, and we have our conversation buffer window memory. We're only going to get 20 of them, and we are going to be using, if you look over here, we're going to be using langchain.chatmodels.openai. The reason why I'm actually using this and not the Langchain underscore OpenAI library is because I ran into a lot of issues while working with that particular library. I kept getting could not pass LLM output, something like that, and that's a really annoying issue. So to escape it, I'm actually going to be using this. And our environment has been selected and it has finally been set up. And I have two tools over here which we have in the internet tools, and if we go over to tools, it's here over here. But first, let's set up Whisper.cpp. Now, this is the GitHub repo. I'm going to be dropping the link also in the description below. And let's scroll down. It's really easy to set up, and we're going to clone the repo. That's the first thing we're going to do. I'm going to be doing it in the modules directory, and I'm going to right click on the modules directory and open an integrated terminal, and I'll paste what we copied, hit enter, and it's going to clone the repo. And once this is done, let's see the next step. We have to actually change directory to whisper.cpp. See? Since we're in the modules directory and it is cloned to whisper.cpp, we can just change directory to, and we're here, and we hit enter, and this command is going to download base.en. That's one of the models that is actually available for Whisper CPP. And let's check this out. Now you can see over here we have then download one of the Whisper models. There are a lot of Whisper models, and if we right click and open a new tab, now let's scroll down, you're going to see the list of available models, and we have tiny, we are to large v3. Now the smaller they are, the less accurate they are at transcribing audio, and the smaller they are, the much faster they are. Like in terms of VRAM consumption, you're going to have less VRAM consumption if you're using something like tiny or tiny en, or if you're using base en compared to if you're using large v3. But if you want better accuracy or more accuracy, you're going to have to go for large dash v3. I can run large dash v3, and you can too, but since I want this to be really fast and I want to reduce the latency, I'm not going to be running it. But if you have more than enough VRAM to spare, you can definitely go for this, or go for the quantized version. And since for the sake of this video, I'm going to be going for base.en. That's what I'm going to be going for. So if you look here, this command downloads this model. And if you want to go for any other model, you can substitute this for this if you're going for the large dash v3. Now let's go back. Since we've copied it and we've pasted it, let's hit enter. Now it's going to download this model, and let's go back to the browser, and the next thing we're going to do is make. So once it's done, we are going to run the make command. So I ran into a network issue while trying to install it the first time, so let's run it again, and this time we're going to just speed it up. So it's done downloading, and let's run the second command, and that is make. Now let's copy the new command, which we'll use to transcribe an audio that's here. So let's see how well it can actually transcribe this audio. Paste it in and hit enter. And as you can see, and so my fellow Americans, ask not what your country can do for you, ask what you can do for your country. Yeah, so it's really perfect. Now, since we want to enable Core ML support, let's go to the next phase, which is pretty simple. Scroll down, you're going to see Core ML support. Now, that's the reason why I added this in our requirements.txt and this. So now let's generate the core ML model from this model which we actually downloaded earlier. And if you did download the large dash v3, you can just substitute this for whatever model which you downloaded earlier. So let's copy this, and we're going to run it. So this should take a while, so let's just speed it up. Okay, it didn't take that long, so let's go to the next command. Let's just copy this and let's run it all. I think this is the one that would actually take quite some time, and let's accelerate the video. Okay, and it didn't really take that much time. So let's transcribe. So since we run this for the first time, it should just take a short while. So let's wait. And if we run it the second time, it shouldn't take this much time. So let's see. Okay, it has actually transcribed. It's really good. It's actually transcribed it perfectly. So let's run it again. As you can see, it didn't take as much time as it did the first time. So let's take a look at the listing function that we have in the voice.py, and the voice.py is located in the services directory. And if we go over here, as you can see, we have the listing function. This function is going to enable us to utilize Whisper CPP. And at first, what it does is we set the transcribed file to the output directory. It's going to create a directory called outputs. It's going to be on the roots directory. It's going to be here in the project directory, and it's going to save this file. If you look here, as you can see, we have this particular function to actually remove the file. We actually commented it out, but you can actually totally leave it in, so it will just automatically delete the file once it's done transcribing, because the transcription happens here. So let's go back to the top. So if you look over here, as you can see, we actually commented out the part that uses socks to access our microphone. And if you want to use socks and you do not want to use the speech recognition library, you can just uncomment this and comment this part out. So as you can see, now if you look over here and the arguments for socks, we have the transcribe file. So basically it's really short, like it's really short compared to using speech recognition, but I do prefer using speech recognition because it has a lot of functions that are really handy. So let's undo that, and let's see over here we have the recognizer and we have the microphone. And if you look over here, we are setting the sample rate to 16,000. This is because that is what Whisper CPP actually requires. The WAV file that we are going to generate from our microphone, it has to be a sample rate of 16,000 and it has to be 16 kilohertz for the bit rates. Like, it's really important. That's the reason why if you look over here in the arguments for socks, we have 16,000 and we also have 16. So as for this, we set the sample rate to 16,000. And we select the microphone from the sources of audio, and we have the recognizer and we adjust for ambient noise. I do not know if it actually makes any difference, but we'll see. Let's uncomment this and we can actually try it out. So we do have this, and then we have say something, and then it listens to it and get the audio data here. And if we look over here, here is where it actually saves the file and it writes the audio, it gets the wave data and it writes it to transcribed file. So we pass the transcribed file over to the process audio function. Now the process audio function is below this, and as you can see, it accepts a WAV file and it also accepts a model name. Just in case we have large-v3 or we have small.en, we have other models that we want to actually use. We can actually specify it here. If you look here, we can actually specify it in the process audio function. We can just, if you look over here, as you can see, it's model name. So because it actually accepts this, but by default it's set to base.en. So it sends it in here. And as you can see, we have the models directly, we have the whisper.cpp, and wherever you actually keep your models, that's where you want to point this to. So I keep my models in the models directory /whisper.cpp/models. Go over here, whisper.cpp, and we have models, as you can see. And if you scroll down, you see ggml-base.en. That's what this is for. Now it checks if it actually exists. If it doesn't, it throws this error that it's not found, and it also checks if the WAV file that we actually passed in actually exists. If it's not, it throws the error. Now this is the full command, so it's going to use subprocess to run this and get our transcribed text, which it cleans up here and it returns here. It's really simple, and at the end of the day, we are going to return the output because that's all we need to pass to the LLM. Because if you look over, let's take a look at main.py. As you can see, set to listen. So it's really that simple. And we have another function here which I added as a bonus. Basically, you can use it or you can actually comment it out and ignore it. This is to actually use the Google Speech Recognition API for transcription. It's still using the speech recognition library, so it's really simple. It doesn't need to set the sample rate you do not need to set it for this one. And as you can see, it listens and sends the audio to recognize_Google. And if it doesn't understand what you said, it's going to switch over to self.listing, which would actually use whisper.cpp. Same thing if the API request actually throws an error, it's going to go offline and use this. So you can just delete this part of the code or you can actually ignore it. And we have Piper, which we set up in a different video, and like I said, I'm going to be dropping the link to that video in the description, so you have nothing to worry about. Now we have the play function, which plays whatever audio is generated by Piper.TTS. Now this is really simple. So the next thing we're going to take a look at is the callbacks. Now if we go to main.py, if you look over here, we have callbacks on the LLM, and also on the agents. Callbacks are really handy and you can use it to do a lot of things. For this particular video, we are going to be using it to send the output over to piper.tts. Now, if you look here, you're going to see on chain error, we have random errors that it can actually pick from. So it would then voice it using Piper. That's if the agent runs into any errors. So we have here on agent finish, we have this, which sends the output over to Piper and it just says it out. And it's really simple because if you look at our main.py, if you look over here, as you can see, the only thing we are doing here is printing the final response. We are not voicing it out, but it's going to voice it out using the callbacks. So that's why we did it here. So it's pretty simple. We can handle errors here. We can run functions here when the chain end, even when the LLM starts, when the chain starts. We can do a lot of things using callbacks, both for the LLM and the agents. And another thing we're going to be looking at is the internet. This part, we have different search engine tools. We have the Excel search tool, we have the Tavily search tool, we also have the DuckDuckGo search tool. Now, this is really basic. If you look over here, this is Tavily search. It's using the base tool class, and we have the name, we have the description, useful to search the web more for better results. This is a search engine tool, formats input as. The reason why I did this was so the LLM, so I'm going to constrain the LLM so it would definitely format whatever input it's sending into this particular tool as this with a query and whatever it wants to know. So it's really simple. And then the argument schema, we use the base model class and we have the field and we give it a description, which is really straightforward. And as you can see, we passed it here. Type. And we have a decorator here, which all it does is tells the LLM that, sorry, I seem to be having trouble accessing the internet right now. So if it tries to use any of these tools that actually require an API call or it requires the internet in any way, it's going to throw that error if we are disconnected from the internet. That's the reason why I actually placed it before these functions. And I did that for all the search engine tools. So it's really straightforward. And another thing we are going to do is we are going to create another tool. And this is going to be a simple tool. First of all, let's copy some things from here. We'll need to copy this is going to be the date tool. Okay. I don't think there's anything else here. And now we can actually import it here. I think another tool that will actually be nice to have is the open weather tool. So let me just copy that in. So to use this tool, the package you will need to install is this. I'm going to be adding it here. I think it's I1. So you can actually, so when you actually run it for the first time, it will automatically install this. And I have actually installed it on my virtual environment. So we have it here. So let's take a look. You can also create a schema. If you can actually create weather inputs, but you do not need to do this. So this is pretty straightforward. As you can see, we're going to be using the weather tool, and it's open weather, and use this tool to check the weather. And we have it's a single input, and we have the argument schema set, and we have this to reinforce the action input format, and we have this, so it's going to run it and check the weather for us at any given location which we actually specify. And if we don't specify any location, it will default to Lagos, and it's pretty straightforward. So something else we forgot to add is handling of parsing errors, and we're going to go over here to the agent executor. As you can see, we have this handle parsing errors, and we're going to set it to a string. So this is a string I'm going to be parsing in here. Check. If you look here, you're going to see the string. Check your output and make sure it conforms. Use the action/action input syntax. If it doesn't call a tool, output only the action input. And as you can see, so if you look over here, we have the vision tool, and we also have the screenshot tool and their argument schemas. Both of them have the same argument schemas, the image query and wait message. And I have a separate video on how this whole thing works, so you can actually check that out. It's going to be in the video description below. And if you look over here at the screenshot, we're using image grab from the pillow library. So, and we are sending everything to Gemini to get a detailed description. See, sending it and sending the image over there. Now, if we're actually using Lava, we are going to have to encode it. So it's really simple, and I can't wait to actually try it out. So let's add it here. Let's import it. Tools, vision. So another tool we are going to take a look at is the file selector tool, which we would use when we actually tell the AI system that we actually want to analyze a file. It's going to use Tikinta, I don't know how they actually pronounce this, but it's going to use the file dialog to just open up our finder. Since we're actually using a MacBook, it's going to open our finder, but if you're using Windows, it's supposed to open your file explorer. And we are going to select the file, and whatever file we actually select and it's actually opened, it's going to call this function, and it's going to send it over to the handle file function over here, which will check the file extension And if we actually have a file type from the tool, if the file type was actually provided, like if I actually tell it I want to analyze this music or I want to actually analyze this MP3, it's going to categorize it. And if we look over here, I actually instructed it that the accepted file types are audio, video, image, and text. So if I say MP3, it's going to definitely pick audio as the file type to pass in here. So that's the reason why I'm actually spelling it out for the LLM. So I'm just reinforcing that. And at the end of the day, it's going to pass it in here. And since the handle file also check the extension, we do not actually need this part, but I'm just going to leave it there. So as you can see, we have this, and we also check if this is texts. That means we want to actually analyze a document, and if the extension is .txt, .doc, .pdf, blah blah blah, we are going to use the partition function from unstructured. And let's install unstructured, because what we're going to be installing for unstructured is so it's going to enable us handle all kinds of document formats. So we'll be able to handle all this. Now, another thing we're going to be installing is this, the rich console. So let's run our AI system. We're going to try out a few tools like the weather tool, the vision tool, and also the date and time tool, just to test it.
Hello, sir. I am MegaMind, your personal assistant. How may I assist you today?
Hello, MegaMind. Open your eyes and tell me what you see.
Please hold on while I turn on the webcam and analyze the image. The image shows a piece of lined paper with several doodles drawn on it in blue ink. In the center, there are two drawings of eyeglasses, one above the other. Both have thick frames, but the top pair is more rounded while the bottom pair has a more angular, pointed shape. To the left, there's a doodle resembling the sun with rays emanating from a circle. Below it, a partial circle is visible, possibly part of a larger doodle that's cut off by the edge of the image. On the right side, a more abstract doodle consists of various lines and shapes. It includes a large circle at the top with a smaller filled circle inside. Below it, a series of vertical lines of different lengths are connected by horizontal lines, resembling a simplified cityscape or bar graph. Partial circle is visible at the bottom right, also cut off by the image's edge. The doodles appear to be done casually, possibly as a way to pass time or brainstorm ideas. The style is simple and childlike, using only blue ink on the lined paper.
Okay, so tell me, what is the weather like?
In Lagos, the current weather is moderate rain. The wind speed is 1.1 mph, direction 253 degrees. Humidity is at 95%. Temperature is currently 26.18 degrees C, with a high of 26.18 degrees C and a low of 26.18 degrees C. It feels like 26.18 degrees C. Rainfall in the last hour is 1.27 mm. Cloud cover is at 99%.
And what is the weather like in New York?
In New York, the current weather is clear sky. The wind speed is 4.92 mph, direction 309 degrees. Humidity is at 61%. Temperature is currently 19.63 degrees C, with a high of 21.08 degrees C and a low of 16.63 degrees C. Feels like 19.24 degrees C.
And what is the time right now?
Time is 4:24 am.
Okay, can you do a research on the evolution of man for me? It uses Tably search too. Nice.
Human evolution began approximately 7 million years ago with the emergence of Homo habilis, also known as handyman. The species was followed by Homo erectus, which is believed to be the first hominid to walk upright. Around 200,000 years ago, Homo sapiens, or modern humans, appeared and began to spread across the globe. The evolution of man is marked by various milestones such as the development of tools, language, agriculture, and technology.
Search for if model if Tesla has released the new Model S. So I'm currently disconnected from the internet. So it's supposed to tell me I'm disconnected from the internet.
I'm currently unable to search for information as I am not connected to the
That's
internet.
the reason why we actually use the decorator. Now that's all good. Goodbye, MegaMind.
Goodbye. Have a great day.
So that's basically it for me on this video. So you can actually play around with all the prompts. You can tweak it however you want. I have a function here that actually handles, if you check here, let's see the vision tool. And if you want to actually use lava to process the images, you can switch this from Vertex AI to this. Basically, it's really that simple. You just have to interchange them. Same thing with the vision tool. And in the vision tool, where you're going to do it is here, the image model. That's where you're going to have to change it. All you have to do is do this, and so it's really that simple. So you can actually switch out if you want to use your Gemini 1.5 Pro, or you want to use Lava. And if you go to the top, you're going to see Lava here, and you have to actually import the Olama library. So that's it for me on this video. It's a very, very simple barebone AI system, and you can build however you want on top of it, and you can tweak the prompt however you want. I know I'm terrible at writing prompts, but you can actually just play around with it, and I'm sure someone will actually create something really, really amazing. So thank you for watching, and until the next one, have a wonderful, wonderful day.